Again, welcome to Data Structure and Algorithm course, CS435. These lectures will present the sorting algorithms. That's for quick and merge. So our main objective again is to go through the quick and merge sorting algorithms and also their time complexities. So first we ask why steady sorting? And here we said there are three reasons for steady sorting algorithm. One is sorting algorithm shows many creative approaches to solving problems. And these approaches also can be applied to solve other problems. Secondly, sorting algorithms are good for practicing fundamental programming techniques using selection statements, loops, methods, and also array. And third, sorting algorithms are excellent example to demonstrate algorithm performance. Also with searching algorithms. So these three reasons are also applied to searching algorithms. In fact, searching algorithms also show us how to implement recursive function. The same thing applies to sorting algorithm. Example will be our quicksort. We are going to implement recursive function. So we start with the quicksort. Here we say the quicksort orders values by partitioning the list around one element, then sorting each partition. So to be more specific, the algorithm first step, we choose one element in the list to be partition element. So again, choose one element in the list to be the partition element. Now, next step, we are going to organize the elements so that all elements less than the partition element are to the left, and also all greater are to the right. Then next step, we are going to apply the quicksort algorithm using recursion or recursively to both partitions. So this means we're going to partition the left side and the right side, and later we join the two together. So this is the reason why quicksort is more faster than selection sort, bubble sort, insertion sort, because we don't need to do much comparisons. So let's see the algorithm one more time. Now here we say that if the list size is greater than one, which means we have more than one items. Now, if we have only one items, then the sorting, we don't need to sort only one. So if the items is more than one, then we can sort it. So first, we do the partition. So partition the list into two sublists. We have one list, we partition it into two sublists. Then we should have the lower sublist and also the upper sublist. So that's why we say we need to get one element, and all the items to the left will be lesser than element, and all the items to the right will be greater than the element. So then we are going to apply the quicksort lower sublist and also quicksort upper sublist. The concept here is recursion. After we finish, we combine the sorted lower sublist and also the sorted upper sublist. So again, I'll go through one more time. Quicksort algorithm. First, we need to choose one element in the list to be partition, the partition element. Again, choose one element in the list to be the partition element. Then we are going to organize the elements so that all the elements less than the partition element are to the left, and all the elements that are greater than the partition element are to the right. Then we apply the quicksort algorithm recursively for both partitions. Then we combine them. So that's the steps, the concept. So let's see an example here. So here we have an original array with some list of items here, and we want to sort these items. Now we decided to use quicksort algorithm. So now if we are going to use, for example, selection algorithm, we look for the lower item, then we swipe with the first one, which will be 1. Then next we move to the next lower, which will be 2, compare If there's no any lower, we swipe. Now, what will make selection more time or do more comparison is that when we take the first element, we have to compare with all the rest to make sure we get the lower items. The second element too, the same thing, we have to compare and make sure we have the lowest item, then we swipe. If it's in the right position already, we leave it there. Now with quicksort, the first thing we need is our pivot. So here we set 5 as our pivot. Then we go through the element to partition. So here we can see that we change, we swipe 5 with 4. The reason why is because the number of items we're going to have. So you can see that we really haven't sorted yet. But first of all, we get the second pivot to be 8. So what will happen here is that we are going to get all the elements from 0 to my left, 0 to 4, because 5 is greater than all of them. Then the next right will be from 8 to 7, because 5 is less than all of them. So that is the algorithm. The first thing, we get a partition element. Then we make sure that all the sublists to the left is lower than the partition element, to the right is greater than the partition element. Then we are going to partition the lower separately, the upper side separately. So first we have 0, 2, 1, 3, 4. Again, we partition it. And then here we say original array is the 4, 2, 1, 3, 0, which is right here, 4, 2, 1, 3, 0. So when we do our partition pivot, we get 0, 2, 1, 3, 4. Then next, the partial array will be 0, 2, 1, 3. This is partition, then we get what we have here. The next, we are going to partition the array again, which is 2, 1, 3. And that will give us 1, 2, 3. Now, this is a very good example here. So again, we have our pivot. We saw that 2 is the lowest value, 7 is the highest value. So we initialize the pivot and also the low value and also the high value. So the next step, we are going to search forward and also backward. So we have 7, we move backward to left, and we have 1 is the lowest. Now, when we move forward from 1 is the lowest. Then when we move forward, we find out 9 is the highest. So now we have our lower value and higher value. So we have low and high. So 9 and 1 is swap. So now we have our value. Then we continue searching. 8 and 0 will be the next ones. We swipe 8 and 0 again. Then we reach almost the end, then 4 and 8. Now here we say when high is less than low, we have to stop searching. Searching is over. So we can say high is less, low is getting high, so we stop. So this means our pivot, we use the 5. Pivot in this right place will be 5. Now we are going to sort the lowest, the sublist to the lower section. We are going to sort it, and upper section sort it, and we combine the two. Now we can see the coding here also. So here we have the quicksort method. We start with the class name quicksort, and the method name also is quicksort. Dollar it in again, we can see we have uppercase and lowercase q, so that make the difference, the names. So here we call recursively the quicksort method. List will be our array. The lower index is 0, and the maximum index will be list.length minus 1. We know the list.length will give us the number of items in the array. So if it's 10, we get 10. But the index will be from 0 to 9. So that's why we say we start from 0, then list.length. So we are calling this quicksort recursively. Now, before we can do that, we need our pivots. and also the partition. So here we have the quicksort. It takes an array again of lists, the first and the last. So the first will be the minimum index and last will be the maximum index. So now we say that if last is greater than first, yeah, then we can do partition. Remember the diagram, when we reach the highest, cross the lowest path and lowest became highest, we have to start the search is over. So here we are going to do searching now. So if the last is greater than first, then we can do our searching. So we partition the list, which is the array, the first element, and the last element, which is the index lowest and the highest. So we partition it, and whatever value we get, we assign as the pivot index. Then when we get the pivot index, the next thing we do is to do our quicksort to the lower side first. Then we have the second quicksort to the upper side. Now we need to write a method for partition, which will be down somewhere here. So we have our method partition. We have partitioned the item in the array called list. The first will be the first index and last will be the last index. Now we assign the first item in the list as a pivot, as we saw in the diagram. So we choose the first element as our pivot. Then we assign the first plus one, move one step index. If the index is 0, we move to the second item because already the first item is our pivot. So we assign the second item as the low, and we assign the last item in the index as high. So we have to do two search. The forward search, we start from the left going forward. The backward search, we start from right. That is the highest index, the last index, going opposite to the left. So now we say that why the high is greater than low. And this condition means we have to keep searching if I is greater than low. Because we can see from the diagram, let's go back to the diagram again. In this diagram here, when we reach this section, we can see that high is less than low because low now is in an index that is in front of high. So that means search is over. When the high is less than low, the search is over. So that is again the concept we have here. So if I is greater than low, we are good to go. We're searching forward from left. So why the low is less than or equal to high, which means we are still at the left going forward. And also the least low is less than or equal to the pivot. If this is the case, then we can move forward. So we increment the low by 1 in low plus plus. That is to search forward. This is a loop. So we keep going forward until one of these conditions is false, especially if, as we saw it in the diagram, if high comes before low or they cross each other, then this condition will be false. And remember here we have an AND operator. So if one of the conditions is false, the while loop will stop, will not execute. So after that, we need to swipe. As we saw the pivoting, we swipe two elements in the list. So if I is greater than low again, we assign the list high to temp, then we assign low to high, then we assign the temp to low. So the temp is high, now we are assigning it to low. So this is in Java. If you want to swipe an element, you need a third variable to place one of the items to the third variable, then take the second item to the first, then take the temporary one to the second. But with Python, I just use the assignment operator, change their positions of the left and right. So I can say X, Y, S, comma, space, Y equal to Y, comma, space, S, which means I'm swapping the item between S and Y. S now goes to Y and Y goes to X. Okay, so after we swap the elements, first we do again forward searching and also the backward searching. Now the next step is to have another while loop. Here we are going to increment. because we say if the I is greater than first, if I is greater than first, and also the list I is greater than the pivot, then we have to go backward. We have to go back. So we decrement the I. Then after that, we swap the pivot with the list I. So if the pivot greater than the list I, then we have to swap. So we put the list I to list first, and then we put the pivot to list I. Then we return the I. As if this condition is false, then we are going to return first instead of I. Then the last section is the test method. Again, here we are just creating a list of array, and then we call the quicksort method to sort the items for us. And after we sort finish, we print it out using the for loop. We know items in array, the best way to print is use a for loop. So that's the code again. So let's continue. So now let's look at the quicksort time now. Now here they say to partition an array of n elements, it will take n-1 comparisons and also n moves in the worst case. So the time required for partition is big O N. That's for quicksort. Now the worst case time, in the worst case, each time the pivot divides the array into one big sub-array with the other empty, the size of the big sub-array is one less than the one before divided. So the algorithm again will require what? Big O N square. Big O N square. We do double comparison. Now with the best case time, each time the pivot divides the array into two parts of about the same size, we let T at n denote the time required for sorting an array of the element using the quicksort. So here we are going to get a big O N log n, because T at n will give us T n divided by 2, because half, plus T n divided by 2 also, plus n. And that will give us big O N log n. Now with the average case, each time the pivot would not divide the array into two parts of the same size, nor one empty part, then here we can say statistically, the sizes of the two parts are very close. So the average time is n log n. Now the exact average class analysis is beyond the scope of this book or these lectures. So again, we can see the coding. So first we have our quicksort. We are sorting an array name data. We are using the generic type as T. Now we recursively call the quicksort to sort the lower part and the upper part. So we start from 0 to data.link -1. Data against the array name. So next, we are going to write the quicksort method, which again takes the array data, the minimum index, and the maximum index. So as usual, if the minimum is less than max, then we good to go. But if max is less than minimum, then we have to stop based on the diagram. So if min is less than max, perfect. We create a partition. So here we assign partition with the data, the minimum index and maximum to a variable name index of partition. Now next we are going to sort the left partition, which is the lower values. So we recursively call the quicksort function recursive. We have the 3 arguments, the data min and index of partition -1. Same thing, we have to sort the right side, so we call the quicksort, and the index of partition +1, and up to the maximum size of the array. Then after that, we need to write the method for partition again. So here we have generic type T, partition element. We have int left and right. Then we have the middle. Middle always is min plus maximum divided by 2. So now we are going to use the middle value as the partition element. So we assign data middle to partition element. Then we move it out of the way for now. So we are going to swap the middle and the mean. Then we assign the mean to left and also the mass to right. Next, we will go through the while loop. We say if left is less than right, which is good, then we can search for an element that is above the partition element. Now, while the left is less than right and data left dot compared to partition element also is less than or equal to 0, then we increment the left. Now we can search for element that is less than the partition element. So here we say while data right dot compared to partition element greater than 0, then we're going to increment the right side. Now next we swipe the elements. If left is less than right, then we swipe data left and right. And then we move the partition almost into the place. So we swipe again, data mean right, and then return right. So next we're going to discuss about merge sort. So we can see the quick sort again. First thing we get the pivot, then we partition, get the partition value, and we make sure that every value to the left of the partition element is less than the partition. Any value to the right is also greater than the partition. So now we sub the two lower and upper side separately. When we finish, we combine the two. Now with the concept of merge sort, rather we are going to break our data into one unit. So we divide, we keep dividing till we get only one element. Then we start to sort them and put them together upwards. So it's kind of a concept of divide and conquer. So with the merge sort, orders values by recursively. So we use recursion here also. So both quick sort and merge sort, the easy way of writing the code is to use recursion. So we're going to recursively dividing the list in half until each sublist has only one element. Then we recombine everything. So to be more specific, first thing we do, we divide the list into two roughly equal parts. We don't care about how the items are ordered. We first divide. Then recursively, we are going to divide each part in half. We continue until the part contains only one element. Then from there, we are going to merge the two parts into one sorted list. Now we sort, then we merge, sort and merge. So we continue to merge parts as the recursion unfolds. So this is our algorithm more specific again. First thing we do, we divide the list into two sublists. Then what we do next, we merge, sort the first sublist. Then we merge, sort the second sublist. Then we merge the first sublist and the second sublist together. So let's see how the concept works in this diagram. So here we have the same number of items. We want to sort using the merge sort algorithm. Again, with the quick sort, we started with taking the 2 as our pivot. Then we look for mass and lower value, and we keep going from there. So here, the first thing we do, merge set means we don't care how the values are ordered. But first thing, this is the difference between quick. In quick, we start with putting the items in order while we are dividing it into 2. But here, again, we just divide the list into 2. We have a left sublist list. We have the right sublist. Then we divide into 2 again. So we have 2, 9, and 5, 4, 8, 1, and 6, 7. Then we also divide the item into 2 again. So we have 2, 9. Now it's 2, 9 separately. So we have, now we are going to combine. So 2, 9 is in the right position. So we get 2, 9. 5, 4, we change it to 4, 5. Then 8, 1, we change it to 1, 8. Then 6, 7 is in the right position. Again, we are sorting increasing order. So here we can see we have 2, 3, 5, 9. then we have 1678. Then we combine the both of them and we have a sorted. So the general steps again is the first step, we find the middle node. Again, the items in the array must be sorted anytime we are using the concept of trying to find a middle value, etc., like the quick sort also. We can sort the list. The lists have to be, our goal is to sort the list. So we find the middle node and we say if all the item to the left is lower than the middle, the items or the item to the right is higher than the middle. So we say, since you don't know the size of the list, you have to transverse it until you reach the middle node. Now divide the list into two sublists of nearly equal size. Then compare the elements of the sorted sublist, compare the two, then we adjust the references of the node with the smaller info. So we have the merge sort list. First of all, recursively, we call the merge sort for the first half. We assign the first half. Then merge sort for the second half. We get the second half. Then the goal is combining them. So we merge first half and second half together. So this is again an example here. We have current 1 and current 2 and current 3. So first thing we do after moving 1 to the temp, next we want to move 2. So we can have the 2, 4, 5 here, then 6, 7, 8. Then from there, again, we combine all together. So we can see, first thing we know again, we do is that we break it into pieces, into one unit. Then the next step, we merge them together or combine together one step at a time. So with the merge sort time, we say let the T at n denote the time required for sorting an array of n elements using merge sort. Now, without loss of generality, and also assuming n is a power of 2, the merge sort algorithm will split the array into 2 subarrays, then sort the subarrays using the same algorithm recursively, and then merges the subarray. So here we have T at n by 2 plus T at n by 2 plus merge time. So again, we can say finally we get big O n log n. The first T at n by 2 is the time for sorting the first half of the array. And also the second T n by 2 is the time for sorting the second half. So the next again is to merge the 2 subarrays, which takes again at most n-1 comparisons to compare the element from the 2 subarrays. So this is the code. So here we are using the linked list node. We call our method rec merge sort. So first we create, again, we know this consists of node and we are using the linked list node. So we assign order head to linked list node. Now we say that if head not equal to null, that is if the list is not empty, then we are going to use the link. So we have head.link not equal null. Now, if the list has moved down 1 node, then we have here we assign the divide list head to order head, and also receive merge sort argument head to a new head, and then receive merge sort order head to order head, and also merge list head and order head to head. Then we'll return the head. So next we're going to write a merge sort. Here we say we receive merge sort first, we assign to the first. So if first equal to no, then we assign no to last. We don't have any item in the receive merge sort. If we have something else, then we assign the first to last. And we say why last.link not equal to no, we assign last.link to last. So the analysis of merge sort here, we say the maximum number of comparison is big O n base 2n. So these are priced for both the worst and also the average case. So dividing the list in half, we can see here we have 305, 657, 790, 120, 110, 8. So first thing we do, we divide the list into half. So we have 305, 657, and 890, 120, 110, and 0. Then we divide into half again, so 3057. And here we divide into half, 90, 120, 110, 8. Then we divide into half. So here we can see that with the merge sort, we divide all the items in the list into one unit of items. In this case, it's 8. Then from here, we are going to build a system. So we can see the list of items we have. We merge again, we give the right side more amount than the left side. Then we merge again the same thing, right side, then the left, then merge to the end. And again, that's another code for the merge sort. So here we have the method merge sort, and we call merge sort again data, the lower index, and also the upper index. So this is recursion. Now, next step is to write a method for mega sort or merge sort. Merge sort will take the array, the first index, and the last index. So while the first is less than mass, or the mean is less than mass, we look for the middle value. So mean plus mass divided by 2, we assign to mid. Then we call the recursively the merge sort with data, minimum value, and then mid value. Then second, so this would be to the left side, the lower side, and the second merge sort is to the upper side of the element. So which will be data, mid plus 1, and mass. Then we call the method merge, again to merge the mean and mass together. So next we have the temp to the section for swapping. So we give the first 2 data to index, then we increment it, we return the index. Now we can also copy the remaining element from the first subarray, if any. So while the first one is less than or equal to last one, we haven't yet reached the end. So we assign the data first one to temp index. Then we increment the first one, and also we increment the index. The same thing, we can copy remaining element from second subarray. If any of these conditions, while the first 2 is less than or equal to last 2, we assign the data first 2 to temp index. Then we increment the first 2. So that will be the conclusion of our lectures. Again, these lectures we cover the basic concept of, again, merge and also the quicksort. So we can see both algorithm again use recursion. So again, wish everybody the best, and thank you.